Hello everyone and welcome back to our course. In this lecture, we're starting our new project, Building Autocorrelation for Crypto Stock Prediction. To get started, we're going to load our data for crypto price autocorrelation with Pandas. For our data, we're going to be using Yahoo Finance. So you can get data from finance.yahoo.com. You can also get the data at the end of this section in the source files. All you have to do is go to Yahoo Finance if you want the most recent data, search up your stock of choice, then select the time period that you would like, and the historical prices and the frequency will be daily. Then hit download, and that will download a CSV file called BTC-USD. In the case of our stock, it will be a CSV file with the symbol of the stock, and then you can use that CSV file. And again, you can also find it at the end of this section. So we are going to load in our CSV file into our files. So you can just drag and drop your file or hit the upload button. You can also upload your file to Google Drive because this is just temporary storage that's refreshed every time you restart or disconnect the runtime. So if you want permanent storage, then use Google Drive. So just click on the upload file button and then select your CSV file and hit open. As a reminder, uploaded files will get deleted when the runtime is recycled. So now you have your CSV file in your files, and we can now use that CSV file. So let's load it into our code. For that, I'm going to import the Pandas library for dealing with data and data frames. I'm going to save our data by using pandas.readcsv. Here, I'm going to pass in the name of my CSV file, btc-usd.csv. I'm also going to specify what columns I want to use from the CSV file, such as the date and the adjusted closing price. You can choose to use all of the columns, but some columns might be unnecessary. Also, do we want to parse the dates? We'll set that to true. Then we can grab data.head to see the first 5 entries in our data frame. So we can see we have an index counting off each row. We have the date and we have the adjusted closing price. You can also print out the data itself to see in a different format. So you can see we have 2,745 rows by 2 columns. Also, if you use the function data.info, then you can get information about the data frame, such as the number of non-null entries and the data type of each column. All right, let's set our date to be the index column. So for that, I'm going to take the data and override it to use the setIndex function. Here you pass in the name of the column that you want to use as your index column. Then you can call data.head to see the results. So now, instead of having an index from 0 all the way to the end, the index is now the date. Typically, you want to use some kind of column for the index that is unique per entry. All right, then we can also add a new column for our daily return. So to calculate our daily return, we're going to make a column to store the daily return. And we're going to take the data at the adjusted closing price and use the function %change. Then we can call data.head to inspect our results. Okay, so we get our daily return per day, which compares the current day with our previous day. The first daily return is nan, not a number, because there's no previous day. So we want to remove all the not a number values from our data frame. For that, we're going to take the data and override it to use the drop NA function. This will drop all of the not a number values. So we have 1 row fewer this time because we removed that not a number column, and actually row as well. All right, so let's also calculate the lagged return. So for that, I'm going to take my data and create a new column called lagged return. And to calculate the lagged return, we take the daily return and we shift it by 1. So I'm going to then inspect my head this time. And we can see that we have this new column, and what we've done is taken our daily return and just moved it down so it goes to the next day. We shifted by 1 index. Let's also add a column for our return difference to calculate the difference of an element compared with another element, by default the one in the previous row. So I want to calculate the return difference. For that, I'm going to take my data and create a return difference column. And to calculate that, I take my data and I take the daily return and I'm going to use the difference function. This will calculate the difference of a data frame element compared with its previous row. So we can inspect our data this time and we see we're getting the difference between the current day and the previous day. All right, so now we have our data loaded and we've added some columns. Next step, we're going to visualize our crypto data with Matplotlib's PyPlot. So don't miss the next lecture. Hello everyone and welcome back to our project, Building Autocorrelation for Crypto Stock Prediction. Previously, we loaded our data for crypto prices with Yahoo Finance and Pandas. In this lecture, we're going to visualize our data with Matplotlib's PyPlot. So inside of our project, I'm going to import matplotlib.pyplot as pyplot. Then we can use the pyplot library to create a new plot. Let's start with a scatter plot of our lagged return versus our daily return. So I am going to use pyplot.scatter to create a scatter plot, and we have to pass in our x and our y data. The x data will be our data at the daily return column. The y data will be our data at our lagged return column. All right, then we can run this code cell and we'll get our scatter plot. All right, so we have our y data with the lagged return and our x data with the daily return. To increase this figure size, just set the pyplot parameters. For example, you can grab pyplot and set the RC params of figure.fig size, and you can set it to 20 by 10. Then if you rerun the cell, okay, now your plot is a lot larger. You can also increase the font size. In a similar fashion, you take pyplot.rc params, and at this time you use the update function, and you update the font.size to something like 18. If you rerun your code cell, now your x and y axis, you can see that font a lot larger, and same thing with any text, like if you had axis labels or a title. Next, let's plot our last period of returns. So I'm going to create a new code cell, and I'm going to take my data at the daily return, and I'm going to take the last year, so the last 365 days, and I'm going to plot them. Here we can then set in some properties as well. If we just run this, then we don't get any kind of text, like we don't have the title or the y label. So if you want, you can pass in a title and a y label into the plot function. But here on the y-axis, we have the daily return. On the x-axis, we have the date. So we can see the daily return is somewhat volatile from about negative 0.15 to positive 0.15. Right, so those are a few visualizations that you can do on your data. Join me coming up next. We're going to perform some more data science on our data, so you don't want to miss that section. Hello everyone and welcome back to our project, Building Autocorrelation for Crypto Stock Prediction. Previously we loaded our data and we visualized our data. In this lecture, we're going to perform data science on our data with the Hodrick-Prescott filter. The Hodrick-Prescott filter is a data smoothing technique. So join me back in your project in a new code cell. We're going to import the statsmodels.api package as statsmodels. If you liked this video, then go to training.mammothinteractive.com. We have tons more content on blockchain, web development, machine learning, and much more. We also have a membership for just $19 a month where you can get access to our 372 course bundle and counting.